So one thing I want to point out, because I saw some that did it to the contrary. I hope I don't have the. Never mind. Just give me a second. So all of these you're supposed to be able to do without using your graphing calculator. Okay, it says no aid from the graphing calculator. So obviously this is something they're going to expect you to know how to do without a graphing calculator on the test. So the first one, f of x equals x. This is just a line, right? Y equals mx plus b. The slope is 1. The y-intercept is 0. Does everyone see how this is y equals mx plus b? Or no, not really. What power is x being raised to? What's its exponent? The first power. Anytime x is to the first power, and that's the highest power, it's a line. Linear. Every time. Line, line, line. So think y equals mx plus b when that's the case. So the slope is 1, y-intercept is 0. So here's some points that are on the line. These are fine. For me, I would have put -1, -1, 0, 0, 1, 1, 2, 2. There's more lines, or there's more points on this line that you could put. It's not only these that are required. Okay? Questions on this part? Finding the points. The domain, what x's can we plug in here? Okay, there's only 2 things that will give me a domain different than all real numbers. Let me say that again. There's only 2 situations that will give me a domain different than all real numbers. What are they? There's 2 things that you're not allowed to do in math. 2 things. Can't take the square root of a negative. So if I have a square root, that will give me a problem. Does this parent function have a square root? No. So I don't have to worry about that. What's the other thing we can't do in math? Divide by 0. That's the 2 unforgivable curses. Can't do it. Not allowed. Does this have a division in it? So if I don't have to worry about dividing by 0, I don't have to worry about taking the square root of a negative, the domain is all real numbers. Every time. So again, there's a couple ways you could write that. I've talked about it with some of you guys. If you want to put it in interval notation like this is from negative infinity to positive infinity. This means all real numbers. That symbol that they've written, it looks kind of like a bolded R. Right, this line and then the R symbol. This just stands for all real numbers. It's shorthand. I didn't see this until I was taking college, like probably Math 300 was the first time I saw this symbol. So if you've never seen it before, that's fine, but they're starting to introduce it here. So I'm just going to introduce it as well so we get familiar with it. But all that means is all real numbers. The other ones that you sometimes use, this is all the integers. That's a bolded C for integers. All the numbers, integers. Rationals is a bolded Q. I think that's the main 3. That's the only 3 I can think of right now that we use. But you probably won't see anything other than that in this class. Is everybody good with the domain being all real numbers? You're checking for 2 things. Can I divide by 0? Can I take the square root of the negative? If neither one of those exists, domain is all real numbers. Now what's the range? This is the one people seem to struggle with the most. Range. Look at all of the y values. So start at the bottom. What's the lowest y value the graph touches? Well, it goes down forever. So it's negative infinity. What's the highest y value the graph touches? Are there any gaps? Is there anywhere that it doesn't touch? So it's everywhere. So same deal, the range is all real numbers. X-intercept, cross the x-axis at 0, cross the y-axis at 0. So the origin is both intercepts. And then we kind of talked about the increasing, decreasing constant. When you're asked for increasing, decreasing constant, you always read it like a timeline, from left to right. So as I happen upon this graph from left to right, it's always going up. As my x's increase, the y's always increase. So that means it's increasing everywhere. So that's increasing on the interval from negative infinity to positive infinity. It's never decreasing. The name of this is the identity function. So you might want to write that down. Y equals x is the identity function. Why do you think we call it that? Because whatever you plug in is what you get out. If I plug in 5, I get out 5. If I plug in negative 10, I get out negative 10. You get out what you put in. It's the same number. That's why they call it identity function. Everybody's good there? Hopefully. Right, here's the answers for the absolute value function. So again, these points are fine. For me, I would have plugged in negative 1, 1, 0, 0, 1, 1, 2, 2. Would be my 3. In this function, do we divide by 0? Do we have a square root? So what's my domain? All real numbers. Every time. If I don't have either one of those, it's all real numbers. What's my range? So we look at the y values after we graphed it. So what's the lowest y value the graph takes on? 0. Does it actually touch 0? It does. That's why they have the equal to sign. Can equal 0. And then what's the highest y value it reaches? Infinity. So this is one way you could write the range. If you want to put it in interval notation, it would look like that. 0 with a bracket. Was that on there? That's so bad. And I never can get it correct. Is that bad for the teaching it for? So bad. X-intercept is 0, y-intercept is 0. At least I'm able to admit my fault. I know that I don't know which word it is. I'm never going to know. I'm 10 years in, I can't remember. So we kind of talked about before, is it still an intercept if it bounces off and doesn't cross it? It still is. So here it bounces off of 0, but that's still an intercept. It's increasing. So as I go from left to right, what's the first thing the graph is doing? Way over here, left to right. The graph is decreasing. So the way I say it is, as I first happen upon the graph, you'll hear me say that all the time. And imagine I'm walking like a timeline, walking along the x-axis. The graph's going down. So as x increases, y decreases. So it's decreasing from negative infinity. When does it stop decreasing? 0. So it's decreasing from negative infinity to 0. And then it's increasing from here forevermore. Right, so for 0 to infinity. And notice how neither one has a bracket. Both the parentheses for increasing or decreasing. I said the right word. I'm so proud. Questions there on that one? That's called the absolute value function. I wonder why it's called that. Because it has an absolute value. Okay. Last one, the quadratic function. I'll spend less time explaining. Hopefully you can kind of see the pattern. It looks like I left off increasing, decreasing, or constant. So where's this increasing on? 0 to infinity. Both are parentheses. Where's this decreasing? Is everybody good with that? People tend to struggle with that increasing, decreasing, constant. That's why I'm spending a little bit of time there. Here we're looking at a cubic function. Cubic function because it's cubed. Am I dividing by 0? Am I taking a square root? Domain's all real numbers. The range, start at the bottom. What's the lowest y value? Negative infinity. What's the highest y value? Positive infinity. Are there any gaps in the graph? No. So the range is all real numbers. X-intercept 0, y-intercept 0. This is increasing forever. As I happen upon the graph from left to right, it's always going up. So it's increasing forever. Questions on that one? So for me, my ordered pairs, I would have -1, -1, 0, 0, 1, 1, 2, 8 will be my 4. I think it's always good to have some on the negative side and some on the positive side. Next one is the square root function. So when I look at that, talking about the domain, am I taking a square root of a number? Yeah. So what did we say? We can't take the square root of a negative. So in order to find the domain, I would take what's underneath the radical, which in this case is x, and I would say it can't be negative. So how do we say it can't be negative? It must be greater than or equal to 0. Everybody follow that? Can't be negative. So if I had an uglier square root, just to give you guys an idea, if I was looking at the square root of 2x plus 5, and I wanted to know what's the domain of this function, am I taking the square root of something? Yes. Well, what is underneath the square root cannot be negative. That's not allowed. So I will say what's underneath the square root can't be negative. That means it must be greater than or equal to 0. And sorry, my zeros. There you go. Everybody follow that? And then we just solve. Subtract by 5. Divide by 2. So the domain of this function would be all x is greater than or equal to -5/2. You guys know that already? You've done that before? Yes, no, no, yes. A lot of stairs. Do you understand why? Because we can't take the square root of a negative. So we always say what's underneath the radical must be bigger than or equal to 0. That's how we find the domain. Okay, you don't have to know this part yet. I'm just trying to fill in if you guys maybe didn't know that. Because we'll get to those eventually. That's how we get our domain. Is everybody good with the range? So from the lowest y value to the highest y value, so from 0 to infinity. Interesting thing here, what do you guys think about the x's they chose? 0, 1, 4, 9. It always gives the outputs of whole numbers, right? So we can't plug in -1. So that one's a bad one to plug in. Well, why did they plug in 2? Because what's the square root of 2? 1.721, I don't remember what it is. But that's not a good point to plot on a graph. So this is one of the exceptions where I would pick different x's. My x's I would pick are always perfect squares. 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Can I keep going? 169, 196, 225, 256. Represent. Yes, sir. That's where I was born, where I was raised. Okay, the last one is the reciprocal function. I said this is the weirdest one. When I teach this in Algebra 1, or when I taught it in regular precal, I never treat it as a parent function because it's so difficult to do transformations with. But that's what it looks like.
Pictures. Junior high FCA has been moved to the high school library. Junior high FCA has been moved to the high school library and is meeting at this time. Thank you.
So they're doing the very formal definition for what the domain is. They're saying the domain is as long as x is a real number such that x can't be 0. So this is just a fancy way to say everything but 0. All right, that's what they're saying here. If we want to do that in interval notation, we can. We could say the domain is from -infinity to 0 and from 0 to infinity, leaving out 0. This is everything but 0. This is another way to say everything but 0. Why is my domain not all real numbers? Am I taking the square root of a number? No. Could I divide by 0? I could. I could have that issue because I have a fraction. So how can I make sure I don't divide by 0? What's in the denominator cannot be 0. If what's in the denominator is 0, it breaks. So again, if I think about this in a harder sense, what if this was my rational function? How could I find the domain of this? Well, I'm not allowed to divide by 0, So what's in the denominator cannot be 0. Solve. So here, the domain would be from negative infinity to negative 3 halves, union negative 3 halves to infinity. Everything but negative 3 halves. So the two ways to find domain exceptions. If there's something under a radical, set it greater than or equal to 0. If there's something in the denominator, say it can't be 0. Those are the two reasons we would not get all real numbers for the domain.